Hello, I am Janel Hanrahan. I am faculty member and chair of the Atmospheric Sciences Department at Northern Vermont University, Lyndon. And I got to this job by entering, I guess, the field of mathematics. So I knew I really liked math, and I earned my undergraduate degree or my bachelor's degree from a small liberal arts institution in Milwaukee, Wisconsin. And I knew that I liked applied math, that I liked physics, that I liked computer science, but I didn't really know how to bring all of those things together. And so my undergraduate advisor had kind of nudged me in the direction of atmospheric sciences when I started thinking about earning a master's degree. And so I ended up enrolling in the atmospheric sciences program, which is also embedded within the math department at the University of Wisconsin-Milwaukee. And I just fell in love with the field. I thought it was incredibly interesting to look at our atmosphere, which is actually a fluid, which is kind of crazy to think about, and be able to take these physical laws of physics and Newton's laws and be able to apply it to not only understand our atmosphere, but also to be able to predict what's going to happen in the future with pretty good accuracy. And so I really enjoyed more of the climate component of the field as opposed to meteorology, which is more short-term. Climatology is examining the statistics of weather, so long-term trends and patterns. And initially, when I had to choose my master's thesis, I was really interested in investigating how the Great Lakes water levels are impacted by natural climate variability. And I was interested in the Great Lakes because Milwaukee is located right on Lake Michigan, so it's kind of right in my own backyard. And I was interested in taking a look at how these natural climate fluctuations like El Nino would impact the water levels, which would tend to fluctuate pretty widely and would have pretty big impacts. So while I was doing this work, I actually came across the climate change signal or global warming signal in my lake level data. It's kind of complicated how that came to be, but essentially the interaction between how the lakes fluctuate and kind of the information that's coming from our climate in terms of like precipitation and evaporation, that connection was changing. And it was a pretty distinct change that started to occur in about the 1980s, which is coincident with the timing of a pretty strong climate change signal that started to emerge. And so this really piqued my interest, not just in how I could connect the Great Lakes water levels to this climate change signal, but what was happening with the climate change. And before this, I really did think that there was a dispute among scientists about whether or not our climate was changing and whether or not humans were the cause. And so I started doing some investigating, looking at the literature, going to conferences, listening to the experts. And I pretty quickly came to realize that climate change is not something that's disputed among scientists. It's kind of like gravity. We just know it's there. And we're working out the details of it. We're trying to really understand how human-caused climate change is impacting regional weather patterns, things like that. And so I continued on working on my master's, and after making the strong connection to climate change, I really had a great, I guess, nugget for a research project. And so I decided to continue on to get my PhD, which is the terminal degree in our field. And then once I was finished with my PhD, I lived in Alberta, Canada for a little while. I worked for the University of Alberta. I was hired on as a postdoctoral researcher. And so for the University of Alberta, we were hired essentially by the city of Edmonton to provide future climate data, precipitation for a future time period, which was going to be obtained by running climate models so that they could redesign their hydrologic infrastructure. And this is because the city of Edmonton and Calgary and pretty much all of Alberta was experiencing just catastrophic flooding almost year after year after year. And they pretty quickly came to realize this is because their hydrologic infrastructure, so just like the size of their pipes and the number and size of their wet and dry ponds, that it wasn't sufficient, that it was based on historical precipitation data. And because precipitation, extreme precipitation, was increasing so rapidly there, they knew that they needed updated information. And so they relied on us to provide that information in the form of climate model precipitation data, which could be projected out several decades into the future. So when I was done there, I ended up applying for and ultimately getting my job that I have right now at Northern Vermont University, Lyndon, where my primary job is to teach. So I teach more of the theoretical type classes within the department because of my formal training in mathematics. So I teach like atmospheric thermodynamics, atmospheric dynamics, how our atmosphere moves and why it moves. And then I also teach the climatology and climate change courses. In addition to that, I also I founded and direct a group called the Climate Consensus, and you can see the flag in the background here. And this is an outreach group of upcoming atmospheric scientists who are interested in engaging with the public, because we think that part of the reason why we're not moving in the right direction right now with respect to really effectively addressing climate change is because, for the most part, people don't understand that it's happening, and they don't understand that scientists agree, and this is a problem. And so let me just, in terms of kind of motivating some of this work, why I'm interested in this outreach and working with this group called the Climate Consensus, I'm going to go ahead and just share my screen. And so hopefully you can see this graph where the black line here is global temperatures. This is based on observation, so actual weather stations that are placed all around the world. And then the gray line is a model. So this is a climate model. And this is all for historical, so starting at about 1880. And what we can see is that the model does a really good job of actually capturing the long-term statistics of our climate system with respect to temperature. And you can see that year to year, you might say, well, it doesn't really match up very well, but that's okay. With a climate model, we don't actually expect it to match up from year to year because we expect it to capture the long-term statistics instead. So you can see that the lines really overlap nicely for pretty much the entire duration of this period. And we can see that both model and observation have a pretty substantial uptick, as I had mentioned previously, starting at about 1980. And scientists pretty much agree now that since probably about 1960 or so, that the dominant climate signal has been that of humans. And that surpasses things like El Nino and other natural climate oscillations that we know about. So we know that both the model and observation are showing this upward trend in global temperature. And we need to think about this in terms of energy within our climate system. So if we have all this extra energy in our climate system, this is available to fuel storms and rainstorms and things like forest fires that we're seeing a lot of out west. And so everything that we've already seen so far in terms of these changes in our weather patterns is largely the result of this uptick in energy now that we have within our climate system. So the reason why outreach is important, and also kind of creating careers in the field of climate change is important, is because our pathway is pretty uncertain. And if we end up along this trajectory, which is called the current trajectory, so continuing to use fossil fuels, being kind of wasteful with our energy, we are truly going to be in a very, very different climate system, even than what we're in today. And in order to address that, we need to have engineers who can help to keep water out of places where we don't want it. We need to have economists who can help to kind of figure out how businesses are going to adapt to this new climate system. But we also have this alternate trajectory, which is the blue line. And so this is really my goal with the climate consensus work, is to try to get us on this alternate trajectory. And this alternate trajectory means that we're being much more conservative with our use of energy, that we're getting our energy from renewable sources, not fossil fuels, which put huge amounts of carbon in the atmosphere, which therefore increases carbon dioxide in our atmosphere, which is a strong greenhouse gas. And we really truly do have a choice in which future we, I guess, travel down. And the problem, though, is that right now we are on the kind of the current trajectory. This is what we call business as usual, and we can go in either direction. And so we need to make that decision as a I guess just as a people, that we're going to travel down the alternate trajectory. But regardless of whichever one we go down, there's going to be a large number of careers in the field of climatology. And let me just skip forward and show you another video here, and this helps to illustrate that point as well, because we're probably not going to end up in the renewable energy future, which is on the left-hand side. My hope is that we're not going to end up on the right-hand side, this fossil-fueled future. And I like this graph because it talks about the age of a person born in 2015. And I know all of you were born earlier than that, but maybe you have a younger sister, brother, or you can just tack on, you know, about 10 years or something like that and get to your own age. And you can kind of see that this isn't some abstract future. This is the future of people who are living on this planet today. And I'm guessing that we're going to end up somewhere probably in between these two scenarios. Left-hand side is a climate system that's warmer than today, but similar to today. The right-hand side is vastly different. Huge amount of energy in our climate system, which is going to change everything, ranging from where we get clean water to where we need to live because of changes in storm tracks and types and intensities. And so again, there's a whole slew of careers that could potentially fall within both of these possible scenarios, and then definitely somewhere in between. So let me just stop sharing my screen now. So the reason why I present this to you is because, first of all, if you want to go into the field of atmospheric sciences, and particularly with respect to climatology, there's a lot that needs to be done. So we need people who want to actually do the research, right? So we have a better understanding of how this extra energy is going to manifest itself within our climate system. But we also need people who are going to be advocates. We need people who are going to go into policy, who can help to inform decisions that are being made that will hopefully result in this climate future that is more sustainable and I guess just better for everything that's on our planet. But also we need artists. We need people who can depict these futures in ways that I can't as a scientist. We need writers. We need people who will cover stories related to climate change. So really anything that you plan to do moving forward, there is going to be some sort of connection to climate change. If you want to go into healthcare, there's been a tremendous number of studies that have shown the connections between climate change and deteriorating health is very strong, particularly with respect to things like heat waves and stress. So if you want to go into atmospheric sciences, great. Feel free to let me know. My email is janel.hanrahan@northernvermont.edu. We'd love to have you. If you're interested in doing more of the outreach type work, doing policy work, doing environmental planning or something like that, great. We also have a degree for that. That's climate change science. Again, you can feel free to send me a message. But even if you're not interested in either of those things, there's so many other possible connections to climate change. And even though this isn't something maybe that you're hearing a lot about now, kind of depending on where you get your news from, this is something that we're going to be hearing a lot about moving forward. So whether or not people believe in climate change, and particularly human-caused climate change, the climate system doesn't care whether or not we believe. It's just going to continue to happen anyway. And so there's two conversations that need to be had right now. Number one is how can we mitigate? Mitigate means how can we stop from getting that Earth on the rate that I just showed you. Number two is how can we adapt? Because we have to adapt. We're in a new climate system. It's going to continue to change. And even if we rein in our emissions today, we're still going to have a continuing, our climate system is going to continue to change over the next several decades, and we need to adapt to that. So given the, I guess, breadth of issues and topics that are kind of encompassed within this topic of climate change, really anything you want to do is going to be related to this. So let me see here. So in terms of what I do on my typical day, right, because we're talking about my career, I guess, is I teach. I spend a lot of time doing course prep, doing research to make sure I'm completely up to date on what it is that I'm talking to my students about. I do a lot of correcting. I make exams. I make quizzes. I have to identify effective assessment tools so I can make sure that my students are learning what I want them to learn. And I also try to stay up to date on what careers are available for my students so that I can make sure that, first of all, I'm training them properly, but also that I make them aware of those opportunities. And in terms of if you're interested in, I guess, atmospheric sciences as a whole, like studying our climate system or even becoming a meteorologist, math is pretty important, physics is important, chemistry, biology is even pretty important. But I would say that we within our program really do train students in these areas. They do take math courses on the side, but even if you're starting at a lower level math, generally that's okay. So I think it's more important that you have an interest in these topics versus preparation. But preparation, of course, is always good too, because it makes your path, I think, a little bit more manageable. So I'm looking at the list of questions here just to make sure I got through everything. In terms of my favorite thing about my job, I get to work with students. I get to work on a topic that I am extremely passionate about, and I feel like I'm making a difference in the world. And of course, there's also a lot of challenges that go with my job, just the pure frustration, I think, sometimes of knowing that as a society, we're not moving in the right direction. But I guess I can use that to fuel our path forward and to make sure that we're really going to make a difference. So thank you very much, and feel free to contact me if you have any questions, and thanks for watching.